Hello and welcome back. So it's Miss Diddy and I'm happy to go over 1.1 polynomial operations with you guys. So today the goal is I can add, subtract, and multiply polynomials by using the distributive property and combining like terms. Alright, so before we get into that, there is some vocab I want to talk about. So if you're super solid in this vocab, you're welcome to go ahead and skip it, but this is vocab I will be using when we're talking about polynomials for the rest of the unit. So if you're a little shaky on it, go ahead, keep watching. Alright, so first thing we want to talk about is this lovely little bit right here, which is the general polynomial. Alright, now it looks a little scary. This is just the general form. So let's go over these bullet points on the side. Alright, where it says n must be a whole number. So when it's talking about n, we're really referring to the exponents n. Okay, I'm going to say whole number, we're talking about kind of like the integers. We're talking about 0, 1, 2, 3, so on and so forth. Right, so we're not talking about no fractions, decimals, negatives, so on and so forth. All of those cannot be our exponent. Alright, so when it says a sub n over here, what it's really just talking about is some number. Okay, we call that some number. Whether that is like 4 or 2 million, no matter what it is, eventually it is just a number. Specifically, we have a specific name for it. We'll talk about it in just a sec, right? But a sub n minus 1 is just a way to notate another number that's different from a sub n. Alright, that's what that notation's really talking about there, as we're just talking about some number there. Alright, so let's look at degree. So degree is the largest exponent. And in this case, that is going to be n. So if we look at our exponents, we'll notice that we have n over here, and then over here we have n minus 1. So let's say n was 4. 4 minus 1 is the same thing as 3. And 3 is going to be smaller than 4. So whatever we do on here, our n is going to be the largest on the leftmost there, and it's going to get smaller as we move over here. Now, let's look at this one for a second. What is the exponent to this x? Alright, well, we should know that is anything, like say 5, this has an exponent of 1, meaning that there's only one of it. So there's only one x. Technically, that has a little invisible 1. Whoops. Wow, what a struggle. Has a little 1 next to it as well. Technically, there was also an x here. Now, if this is going from left to right and it's getting smaller, the exponents are, what would we expect the exponent on this x to be? Like, what would we expect this area to be right there? Well, it's 0. Because anything to the 0th power is just 1. Right? That's an exponent property, which means that it's actually 1 times some number a sub 0. Okay? And the reason why we don't write that x to the 0th there is simply because it's a lot easier to not write anything, because it's essentially just multiplying by a 1. So not too bad there. Okay, so leading coefficient. Leading coefficient is the number, it's a little, there we go, being multiplied to the variable with the highest I'm going to rewrite that. Highest. Oh my heavens. Please hold. There we go. Highest exponent. n. Right? If n is the highest exponent, then your leading coefficient is always going to be the number being multiplied to it. So in this particular case, our leading coefficient is always going to be whatever number is getting multiplied to that variable to the nth power, or the largest power. All right. Now, there's another term that's a coefficient. A coefficient is just a number multiplied to a variable. Variable meaning letter, right? So let's do this in orange. So coefficient, that would mean that this a sub 1 is a coefficient, this a sub the n minus 1 is a coefficient. Now, the green is a leading coefficient, but we can also just call it a coefficient of x to the n, right? Now, this one down here, it doesn't have an x, it doesn't have a variable, so we don't call that a coefficient. We call it something else. It's called a constant. The reason why it's called a constant is no matter what x ends up becoming, it will not change because there isn't a variable attached to it. That's why it stays constant, hence the name constant, right? So it is the number without a variable. Okay. Now, not all polynomials are going to be in the particular form of our general polynomial, but we can put them in that form, and that is called standard form. All right, the standard form is the general polynomial, where you start with the highest power, and go down. Now, power, in case you don't know what power means, or kind of need a refresher on it, that's an exponent. Okay, those mean the exact same thing. So, meaning that if 4 was indeed our n, and using the example that we kind of mentioned, if 4 was indeed n, that would make this exponent 3. And we'd have another term with an exponent of 2, exponent of 1, exponent of 0. Right? The powers are going in descending order as you move left to right, and that is standard form. All right? So let's kind of see what some of these terms in action are. Okay? Now, whether you remember these classifications on the left, I don't care as much. All right? The only one that we really talk about a ton, or at least what you should have already talked about a ton, is quadratics, where the highest power is a 2. Okay? So let's look at degree. So before, we said degree was the largest exponent. So let's look at these bottom examples. So we have a 3, a 2. Technically, there's a little 1 there. What's the highest exponent out of all of those? It's a 3. So that's why we say that the degree is a 3 for this particular polynomial. The degree is 3 because that's the highest exponent. Yes, there are others, but the highest is a 3. Likewise, on the line above it, the highest exponent is a 2. So the degree is 2. Likewise, we have a 1 right there, and that is the highest exponent. There is another term here, but there's no variable attached to it, right? And if we had to attach a variable, it would be that x to the 0th, which 1 is still greater than, right? And that's why the degree is 0 when we have just the number, because there's that x to the 0th, that invisible 1 always with it. Now, this is a special case, and I don't really talk about this because it doesn't come up, is this top case right here, where it says f of x equals 0 and the degree. Because 1 technically has a degree of 0, 0 doesn't have a degree. It's really interesting. I can totally go into the history of mathematics and prove it to you why it has a degree of 0, but it would probably be a waste of time. But if you're really curious, send me an email. I'm happy to go over it with you. I think it's fascinating. You probably don't, but that's okay. All right, so let's look at the next example. So example 1 says, write the following polynomial in standard form. Identify the degree, leading coefficient, and constant. All right, so we need to find the degree. Oh, heavens. Spelling's a struggle today. Degree, coefficient, leading coefficient, F-I-C-I-E-N-T, and constant. Okay, so the first thing we need to do, we need to put this in standard form. That's going to help us identify our bottom 3 vocabs the most. All right, so I look at this and I say, all right, if we start with the highest exponent and then we go in descending order, going down, what would be the highest exponent here? So we have a 9, 11, 7, 2, 4. There's no exponent on the last. Out of all of these, the 11 is the greatest. So this term, 37x to the 11th, goes first. And then we go with the next highest exponent, which is the 9 over here. So we write that term, negative x to the 9th, next. And then we keep going in descending order. The 7 is the next highest exponent. So minus 72x to the 7th. And then we go with the next highest, which is the plus 4x to the 4th. Positive 4x to the 4th. And then we have the minus 2x squared. And because it doesn't have an exponent attached to it, the constant is always at the end, that last number. And now we're in standard form. So degree, once we're in standard form, is a little easier to spot because it's always going to be that first term because standard form always starts with the highest exponent. So the degree is just the exponent. It is 11. The leading coefficient, remember up here the leading coefficient was the number being multiplied to the variable with the highest exponent. So here's our highest exponent, and what number is being multiplied to the x to the 11th? Well, that's going to be the 37 here. So 37 is the leading coefficient. Constant, as from our definitions from above, was the only term without a variable, and so that would be our negative 7 at the end. Okay, make sure you do include the sign. Because that negative is part of the 7. Okay, so the sign is included. Alright, so let's go on to this next little part of the question, which is what... Ooh, typo. We're just going to say what is the coefficient and degree of the second term? Right, well now that we are in standard form, we can say, alright, well this second term right here is negative x to the 9th. Now, this is because we were asked to put it in standard form. That's why we're considering this the second term. Now, if we weren't asked to put it in standard form, this would be the second term there. Okay, so depending on what you're asked, if you weren't asked to put it in standard form, just take it how it was. Okay, there's one problem on your homework that talks about all the vocabulary and it doesn't ask for standard form, so keep that in mind. Alright, so if it is in standard form, the second term is the x to the 9th. Okay, so if we look at that, negative x to the 9th, and I ask the question, was the coefficient? When we're looking at just a single term, then everything else that was with that negative x to the 9th doesn't really matter because we're looking at just this portion. So what's the number being multiplied to our variable in just this portion? Well, it's negative, so I know I have to have a negative there. But what's the number that's always there? Like there's always an invisible 1. And that is our coefficient. Alright, so the sign is included with the coefficient, always. And the degree, even though it's not the highest in the polynomial, the degree for that term, the exponent for that term, is a 9. Alright, so that is your vocabulary for polynomial operations. Go and check the next video in order to do the operations. Have a great day!